Alright, welcome to the CAB302 Week 7 lecture on data connectivity. Let's just make sure this thing is live. Okay. So this week's lecture we are looking at databases and how we make use of those from a modern programming language like Java. So switch over to this. Okay. So what we're aiming to do this week and in next week's practical is understand the need for consistent data abstraction for client programs so that we don't need to write specific database code for each individual database that we use. And we're looking to get some experience with working with a specific mainstream example, which is JDBC, or Java Database Connectivity. This is not the only vendor-agnostic database connectivity standard. We will look with another one, but because we're using Java, JDBC is the most popular solution. So we'll be looking at using that and wiring up an application that makes use of a database such as MySQL. In this case, we are using MariaDB, but MariaDB is just a open source continuation of MySQL, an open source fork. So it's pretty much equivalent in most aspects. Whenever you find documentation talking about MySQL, most of the time it will work with MariaDB as well. Okay, so a very brief introduction to databases. This is not a database programming subject, so we won't be focusing on it. But the idea with databases is that a database is an organized collection of related data that's typically stored on disk. And what you have is a database management system, which is software for creating and managing a database. Now, relational databases, which are a pretty dominant paradigm in terms of databases, store data as relations. So the database is made up of these tables, and these tables describe how specific attributes relate to something. So this particular example here is rather old. Australia's had about 20 new prime ministers since then, but you get the basic idea. We have names and we line them up with, we have attributes and we have them relating to some other kind of attribute. So the name John Howard is associated with the age 78 and so forth, and you can have as many different attributes as you want in a particular table, as many as makes sense for this particular domain. Now, another dominant paradigm in database programming, specifically with relational databases, is the use of a common language called SQL, or Structured Query Language. And it is the dominant standard for interacting with relational databases. And there's various commands in SQL that we use in order to manipulate a database. We've got select to get data, we've got update and delete to change data, insert into to add data, and we've got various commands for actually manipulating the databases and tables that our application makes up. So in terms of how these things are divided up, even though we are making use of a single database server, such as MySQL, MariaDB, OracleDB, Microsoft SQL Server, etc., those database servers consist of, can store information about a number of different databases. And so these databases tend to be fairly separate things. Most of the time within a particular application or whatever, you would just have one database and you would divide things up between different tables. Though occasionally you might have need for multiple databases. Usually you would have one database for each particular application, each separate application that makes use of different things. So if you've got your forum software somewhere, that might run on one database, and your file management software might run on some other database. And you assume that the two won't necessarily meet all that often, although you can create queries that actually reach across multiple databases. Most of the time, in order to structure your data, you'll be creating these tables, and each table is something like this. It's a series of rows that has a number of different attributes, and these attributes have different types. So you can have certain attributes that are meant to take text, others may be designed to take numbers, and there's other things. You can put binary data in there and stuff like that. So those are the very basics of SQL. These are just some example commands. SQL commands end with a semicolon. That's how the interpreter knows that the command is done. And I've actually got an SQL database running at the moment. So I've got MySQL running over here, running on port 3306. And I've also got another command line here that I can then make use of to log into this database. So I've just got the default settings here at the moment, root with no password, and I can then view my databases. Note the necessity of the semicolon. If we forget the semicolon, then the interpreter thinks we're still adding stuff. Okay. Oopsie. Alright. So these are just some basic commands that we can make use of. Let's go back to this and try some of these out. So we've done show databases. We can use a specific database. This is basically shorthand. We can actually, do something like describe CAB302.names in order to access a particular database without having access a table within a database without having selected that database first. Most of the time you tend to perform a lot of operations on the one database, so we will use CAB302, and then we can reissue that describe command and just put in names. And also, show tables. We've only got one at the moment. And describe names. Okay, so we can see that this particular table has two attributes or two fields. We can see the type. Varchar just means that it can hold 45 characters of character-based data, in other words, a text string. There's other types that are more suited to holding very large amounts of text. Varchar is usually only used when you have very small amounts. So we have, neither of these values can be null, they can't be missing. And a name is the primary key. Now, the primary key doesn't really affect what you can actually do with a particular database for the most part. There are some limitations on a primary key that other values might not have, but for the most part it's actually pretty descriptive. So the other field there is age. It is an int 10. That basically means a 10-digit integer. And it happens to have a default value. So if we created a new row, we would have to specify a name. But if we specified a name, it would automatically get a default age of 0 and the row would be successfully created. So we wouldn't have to specify everything in the SQL command to actually insert a row. Okay, so the most powerful command, or one of the most commonly used commands in SQL is the select command. So we can do a select star from names, and that would just give us the entire contents of the table. So what that means is that we're asking it to select all columns from this particular table. If we wanted to specify a particular attribute, we would just select, say, age. Or we might select name and age. Or even, age and name. We get the columns back in the order that we asked for them. But star is just a shorthand to let us select everything. And we can also issue some we can also make use of some special things like a where clause, which we can use if we want to access a particular row. As databases get quite large, we often don't want to be retrieving everything from them. And SQL databases like MariaDB are designed to be quite efficient at selecting a particular row, especially if the row that we're doing a where clause on happens to be indexed. So if we select star from names where age equals 57, we get, those two. If we select it, we can also do things like age is less than or equal to 62, and so forth. I said before that these were prime ministers. Peter Beattie has never been a prime minister, so I guess I was wrong about that, but you get the idea. They're politicians anyway. So yeah, the other thing that's we have an example there is collect/count, which will give us the number of rows. We can also have that match as well. So age equals 57, 2. So fairly basic stuff, and we can insert and delete rows. I won't demonstrate those, but those are fairly straightforward. Okay, so that's enough about SQL. The thing that we're most interested in this lecture is how we make use of an SQL database from within Java. So, database and applications. N-tier applications remain a sort of dominant force. The idea is that we want to split up our applications into multiple tiers. So we have the data in one area, business logic. So these are things that, they might depend on outside legal rules, for example. We might encode some of the tax law into our program, so that would be considered business logic, as is any other logic that is not really, stuff that is decided by the programmers, but stuff that is decided by the business people. And, the presentation layer, which is where everything gets demonstrated or displayed to the user, and the user can edit things. So basically the user interface level. We want to make use of database systems for performance and flexibility, because once you get, once you're storing data beyond a certain point, you might, find early on that just a flat file, so a file with a bunch of text lines in it that contains your data, or maybe it's XML format, or maybe JSON format. But, a flat file tends to be very convenient because you can edit it in a text editor and then make use of it in your application. But the flat file doesn't really give you a lot of advantages in terms of performance and flexibility and its usage. You have to essentially code all of the operations for retrieving data from it. And if you, depending on how careful you are, you may be able to make those fairly fast. But the idea there is that, a text file isn't particularly ideal for efficient retrieval and storage of structured data. Instead, we want to make use of a database for that. But what if your database vendor is evil? What if your database vendor says that changes their licensing agreement or increases their price or something like that? What if the new version of it isn't all that good? Or what if a competitor's database introduces a new version and adds a bunch of new features or better performance that you want to make use of? You could change your database vendor and install a new database, but how can you do this without rewriting the logic and presentation layers? Because, of course, the database has nothing to do with the presentation. You can switch to another database and it should pretty much leave things visually intact. The database also has nothing to do with your business logic, because, that's not something that the business people would really care about. They don't care what database you're running for the most part, unless it's in terms of, this database vendor happens to be cheaper or this database vendor happens to be free. The idea there is that it's more either at the data layer or very close to it. So we want to be able to change things without needing to really change too much in terms of our program. So we'd like to be able to program our application in a generic way that will work with any kind of database, and then when we switch database systems, we just need to, change some parameter somewhere perhaps in order to use a different database. But of course, all of these databases have their own individual APIs. Like MySQL has its own C API, for example, and stuff like that. So we have these individual APIs. They're different for each database, and your code will depend on it if you happen to use these APIs. So what we want is a vendor-independent data API. That way we can just learn that API instead of all of the ones for our different databases, and if we need to change our database, we can just make use of that particular API. We can just make use of that API and switch out the underlying database without needing to rewrite our code. So that's how JDBC came about. Or more specifically, it came about as a result of an earlier standard called ODBC, or Open Database Connectivity. And the idea behind ODBC and the later JDBC was that you would have one API that was generic enough to handle any kind of database. Any kind of SQL database, anyway. Because ODBC and JDBC are designed around the paradigm of, you write SQL queries and those get issued to the database. And so with these, you just have the JDBC, and each JDBC and each database or each database server that we have happens to have a different API. What we have is a driver that connects to that API, and the ODBC or JDBC app API can then connect to that driver in order to communicate with it and allow us to run SQL on a generic database without needing to worry about exactly what database is running on the back end. And the idea is that the program connects to that driver, and the driver handles all of the specific details of each DBMS. So that driver itself would normally make use of the specific database management system API, but it does it in such a way so that you can just make use of the driver in order to handle that. ODBC drivers had their own versions of SQL, but this was later unified with SQL standards. So SQL used to be and in some ways it still is, it used to be a bit of a Wild West in terms of all these different implementations of the same basic standard. The simpler stuff, select star from table name, would still remain intact, but the more advanced features in particular would typically have different versions of SQL. But this was sort of helped with later SQL standards. So ever since Java 1.2, Java has had the Java Database Connectivity API, using some of the lessons learned from ODBC. So it was based on being an improved version of ODBC, as well as being something specific to Java. And one of the things that the JDBC made use of originally, and it's still around, is something called the JDBC ODBC bridge. And the idea with that is that rather than needing to have every database automatically, rather than needing to have a driver for a JDBC driver for every database straight up in order to communicate with these, instead you could make use of this bridge. This bridge was itself a JDBC driver, and it will connect to an ODBC driver in order to talk to any database that happened to have an ODBC driver, but no JDBC driver. So this was most important early on when, the JDBC standard was just emerging, and there were a lot of existing ODBC drivers, so this would allow you to make use of those as well. But if a JDBC driver that's specific to your database exists, it's usually better to make use of that. So database vendors provide their JDBC drivers, even Microsoft SQL Server has one. And programs include instructions to instantiate the driver, which then instantiates the connection. So SQL statements from the program are then passed directly to the DBMS for them to handle. So for the most part, these JDBC drivers don't handle interpreting or translating your SQL, they pretty much send it across. And, JDBC was sort of considered to be a declaration of independence for Java in terms of connecting to databases, because Java itself one of the original goals of it was to achieve platform independence, because you could compile your Java program and have it run on any particular platform that you like. With JDBC, this gives your program database vendor independence. Once you make use of JDBC, you don't need to worry if your database vendor turns out to, or if your initial database choice was not correct, because you can just migrate to a new database and you won't need to rewrite any of your code in order to do so. Other Java technologies can make use of this, so Java server pages, for example, that's a technology used for basically creating website backends making use of Java. And the idea with that is that the Java code then communicates to a database via JDBC, and that allows you to get this sort of dynamic web application. So the old LAMP model, so Linux, Apache, MySQL, PHP, can pretty much entirely be recreated in Java using Java libraries. The API for the JDBC is provided in the Java SQL package, with some later extensions added to Java X.SQL. So this is kind of like with Java.awt and Java X.swing that we looked at in the GUI lecture. So, developers of JDBC hope to provide a pure Java implementation for database access, but of course some people have hoped for world peace as well, and it doesn't necessarily mean you're going to get it. And there's some problems with that. So there's too many different databases and too many different protocols for communicating with them in use. And as a result, vendors couldn't agree on any kind of standard protocol for communicating with databases. So instead, we get a Java API for SQL access, plus a Java driver manager API for third-party drivers, and a mechanism for connecting the drivers to specific databases. And of course, the vendor-specific vendor-specific drivers are generally the fastest and best way of making use of that vendor's database, rather than making use of any kind of bridge or one of these other alternatives. So this is just a diagram showing how this stuff generally connects together. We've got the Java application, the JDBC driver manager, and alternatively, we can either make use of the JDBC ODBC bridge and connect that to an existing ODBC driver, which then connects to the database. Or if there's a vendor-supplied JDBC driver, we make use of that, and that directly connects to the database. And that way, our Java application can connect to whatever database it likes. So how do we actually connect to one of these? Well, there's generally a fair bit of boilerplate code. I don't think it's too boilerplatey, but certainly the older versions of JDBC are a lot more boilerplatey. But there are parts of it that are, and so either way, we get a connection to the database, we set up our SQL statements, and we interact with the database through that. Finally, once we interact with that database, we can retrieve, say, result sets that contain the results from our SQL queries. So stuff like our select star from table name will go in our result set, and then we can go and basically present that to the user in some fashion. So we would present that through a GUI application, for example, things like that. Sometimes we even close the connection properly. It's a good idea to close your connection and to close your statements and things like that once you're done with them. It may not necessarily break your application immediately, but it's a good idea. So, okay, the old way of connecting to connecting to a JDBC driver was to make use of the class.forName method. Now, the class.forName method is basically a way of retrieving any class just by giving the name. So things like, java.lang.object could be passed to this java.forName method. This is a reflection method, essentially, and what it does is that it just gives you that class, so you can then do things like instantiate that class or call methods on that class, and so forth. And so this static method forName instantiates a class having the name of the string passed to it. So you can make use of this in order to get, a class without actually knowing its name at compile time. And it will then load the driver class named in that particular string, which you can then make use of in order to talk to that JDBC driver. You can make use of this in your own applications for connecting to, say, generic Java libraries that you've just put within your application. But we won't focus too much on this because there's a better way of doing it. The source URL is a protocol used for the database connection, so that includes the name of the database, the IP address or domain name of the server to connect to, and the port number to connect to. So it will then connect to that IP address and that port and attempt to open that particular database. The IP address or general address, so if you have computers that are named, you can usually just give that name instead. It will be looked up via name server lookups as per usual. And this could be either the same machine or a machine on a different server, as long as you've got things like firewalls set up to allow connections. And so that's the old way. The new way is this connection interface, and the idea is that driver manager is a class that has a static method called getConnection, which makes use of the information from that URL. So this source URL, which tells you the protocol and all that, it gets information from there in order to work out what database driver you want to load. And so, driver manager just includes some stuff for basic driver management. And JDBC drivers can be customized. For example, in a properties file, you might specify that you want, say, this particular information if you want to support a bunch of different SQL drivers, as an example. So, in Java 6.0 onwards, we removed the need for class.forName, which we didn't really want in the first place because it's kind of an ugly way of doing things. And instead, what happened is that JDBC driver jars have a special file within their manifest. So jar files are just zip files. You can have a look in them and see this stuff. And the idea is that it contains information that can be used by the driver manager class in order to find this database. The jars, like I said, they're just zip files, but they're designed to be created with a special program, and this program is called jar. When you download the JDK, you will get that jar program in there. And it's used both for distributing Java libraries, so stuff that people are supposed to load into, load as dependencies, and make use of the classes and methods inside it, or for distribution of standalone applications. You can put a class with a main method in there, and that can then be run, rather than needing to have all these separate class files out. So this is the sort of modern way of connecting to a particular database. And I'll just quickly demonstrate that in here. So I'll just create test DB, and I'll give it a main method. So args. Alright, so what we want here is driver manager.getConnection. And when we use driver manager.getConnection, we give it a URL. And that is a special URL that is used to show where our particular database is, where our database server is, and how to connect to it. So since we're using MariaDB, we want I better go and import this. We'll import that. We'll add that exception. Okay, so MariaDB // and then now we want the host name. So localhost and a port. I've got MySQL running over here, so I can see that it is running on port 3306, which is the default. Finally, we want the database, which I think I've called CAB302, yes. So I can make use of that. And this getConnection method here returns a connection object. So I can go and do connection equals that. And that will give me a connection I can use. Okie dokie. Now, I said before that you'd better make sure to close the connection. I think that's a good idea, so I'll just close it now so I don't forget about it. But what we can do is actually just run that, and it will generate an exception if it fails to connect to this database. So we should be able to find out pretty quickly if this is working or not. It's not working. And it's not working. Why is it not working? No suitable driver found. What that tells me is that maybe we don't have no, we do seem to have MariaDB in there. Let's just have a quick look. Oh. I should have been looking at the lecture. Because the lecture says, yeah, JDBC and then the JDBC driver name. Okay. So now we'll give that a go. And with any luck, we'll get another error. This time we couldn't connect to this particular... okay, it's trying to connect to my, using my username and password here. That's because I haven't passed in a username and password. Give that one more go. Okay, it's not displaying anything at all now, but no news is good news. Alright. Okay. What we've got here is some code that actually prints out that particular error message, but what we have here is good enough. Okay. So the javax.sql package also provides some more advanced stuff used for server-side database applications. So you can make use of this in some ways actually to so you make use of a JavaX SQL data source instead of the driver manager, and that can be quite useful. So that gives you, access to connection tools, which can be beneficial for server-side applications. The idea is that these database connections happen to be fairly expensive. You don't want to typically have more than one of them going, or certainly not several going, and they take a bit of time to actually set up and shut down. So what you want to do instead is make use of a connection pool, which will reuse these database connections where possible. The idea is that they basically have a bunch of database connections, and when a database connection is requested, the application returns one not in use from the pool. This is very similar to thread pooling used in multi-threaded application development. When the connection is finished with, it is returned to the pool for other code to use. Okay, so that's the basics of creating a connection. Once we have a connection, we want to actually do stuff with it. So, when a connection is established, we can make use of it to execute statements. And statement is an interface that has a bunch of different sub-interfaces under it that are used for more specific things. None of these are actually classes themselves. Instead, you'll get basically classes that implement these interfaces within the JDBC driver. So these will be sort of special to whatever driver you happen to be using, but you will just make use of these through the statement or interface or these two sub-interfaces, so that doesn't really affect you all that much. Just means you can't just go and create one. So the statement interface represents a basic SQL statement, and that's a very simple way of doing things. So you can basically take your connection and you can, what are we going to make use of here? There's a few things. Create statement is one way. We can just get a very basic statement. Import that. So now our statement, if we look at its methods, has a bunch of different things. Execute query is probably the easiest one. And that will just execute a given SQL query. So we can say select star from names. And that will also return something itself. That will return this result set thing, which we will look at a bit later. The other two types are for perhaps more specific applications, but they tend to be, either more secure or more performant, or both compared to the raw statement interface. So one is the prepared statement, and that represents a precompiled SQL statement that can offer improved performance, but mainly convenience and also security. So if you're familiar with the classic attack called SQL injection, the prepared statement is the JDBC's method of getting around that. If you make use of a prepared statement, an attacker can't inject SQL that you weren't planning on running into your query. Finally, there's callable statement, and this allows, and you can actually make use of callable statements just through a statement. You can still use the call SQL command, but JDBC actually provides a better interface to that called the callable statement. And the idea is that this allows JDBC programs to access a stored procedure that's within the database itself, and that offers a great deal more improved performance. So the idea with stored procedures is that you can actually create procedures, and those are pretty much SQL or an SQL statement or multiple SQL statements that can be parameterized, and these will just be executed within that particular database, and those are actually stored within the database itself. So if you want to actually change what a callable statement does, you just need to modify the database. And this is good because it means that if this is, say, business logic, that means that this particular instance of business logic can just be stored within the database. It means that you don't need to change the application, which is essentially the presentation layer, in order to change that business logic. So this is quite a useful thing. And it also gives greater performance because the SQL server that you're using is able to spend as much time as it likes preparing things so that we can make use of them. So statement, we get connection.create statement, and we can perform these things. So for commands, we can make use of the execute method, and that's where we want to actually do something. I'm not going to do drop table names because it's useful to actually have that table around, but that's basically the idea. If you want to execute something, especially if it's basically a command that doesn't require any output, or where the output is just going to be, say, whether it's successful or not, then it makes sense to use execute. For queries, that is commands that will then, return results, you'll want to make use of the execute query method, where you just pass in an SQL query, and that will give you a result set back, which you can use to navigate through those results. For your SQL update queries, so that is things where you actually change the results in the database, you can make use of execute update, which is designed for using for SQL commands like this, where you're actually using, say, an update call to change the contents of that particular database. It's just most designed for that, and what it does in that case is that it actually returns the number of rows that were changed in a particular update. So this, for example, will change all of these particular names. That will change one person's age to 21, where that person's name is Colin Fidge. And that will return the number of rows that are affected, which will be either 0 if there's no one named Colin Fidge in the database, or 1 if there is someone named Colin Fidge. So we can pretty much show that here actually. So say execute update, and we can do something like update names set age equal where name equals good old Peter Beatty. So we'll go and update that, and then that will return the number of rows, so we can see if it was successful or not. Rows equals that, and then we can system out print line rows affected plus rows. Alright, so let's run that. Okay, so that's changed one row in that particular database. We can then go to our window here, select star from names, and we can see, alright, we've successfully changed Peter Beatty's age. What was that before? 62. So change that back real quick. Make sure it worked. Good. Okay. So that's the basics of an execute update. Reusing a statement object implicitly closes the previous result set. So we'll look at result sets in a bit, but they're the thing that you get in as a result if you call execute query. And basically a result set only lasts for until basically you make use of that statement object to call another, to do something else. Well-written JDBC code should close everything explicitly. So once you're done with the statement, you should close it. And once you're done with a result set, and I'll just go and get one now, statement.execute query, star from names. Better import that. Once you're done with a result set, you should close that as well. Okay, so that's the basics of statement. Prepared statement basically allows us to create a parameterized statement where we actually provide our SQL query, but we leave some stuff out. So if we, for example, actually that code from before would be good here. Let's go and take that and we'll close the statement like we're supposed to. Okay, so rather than using a statement to do this, we'll make use of a prepared statement. So in order to get this prepared statement, we just need to do create prepared, is it, no, it's prepare statement. See, prepare statement, and then we'll basically make use of this. So in this case, this is an insert into example. As you can see, question marks are used to replace the values that have changed. And this can be used within, say, where clauses and things like that as well. So we could say, update names, set age equals question mark, where name equals question mark. I think that should be good. We need to import that. Okay. And what we do once we have that is that we need to, I don't know if we actually need to clear the parameters first time, but it might be good if we're actually reusing this. We can then set the values that are being used to parameterize this query. So our first value here is an integer, so we'll just use centInt. Now, in JDBC, unlike everything else in Java, in JDBC, indices are 1-based. So they count up from 1. The first parameter in that case is 1. The second one is 2. So we want to set that to, let's just say 99. And then statement.set string 2, and we'll just Peter Beatty. See if this thing works. Once we've set up all the parameters, we can then execute an update, and that works pretty much the same way. So I can statement dot execute update, and we can see the number of rows that were affected by it. So let's just run that. There we go. So we can then have a look at that. And the idea here, the reason why this is better than, say, just creating, just using a statement and then pasting together an SQL string with these values, is that if you get some of these values from, say, a form or something like that, and they happen to contain SQL code, there's no way of an attacker actually doing SQL injection making use of this. They can't manage to inject their own SQL code. So the common thing is to, let's say, rather than having name, we could say, let's say this was just being pasted in. So rather than P to B, an attacker might have paste in, say, John Howard, and then put in an apostrophe to close that, and then a semicolon to end that particular statement, and then, say, put in some more SQL code in order to do something else that we don't want them to do. But if we're just making use of something like this, then it's actually pretty safe. So run that again, get the database back to how it was before. Okay. Finally, there is callable statement. And the idea is that if your database management system provides stored procedures, which a lot of them do, the simpler ones, so stuff like SQLite, I think, does not support stored procedures. Anything that's a very basic database system that doesn't give you any kind of, that's, pretty much manipulating a flat file, usually won't have stored procedures. But most major database systems, including MySQL and MariaDB, do support this. And so if you have those, you can make use of those through the callable statement, which is where you can make use of these certain callable procedures. So we can actually, I think we can I was trying to remember. I think we want to make use, I think show procedure status is what we can do to show, yeah, we can use this to show all of our stored procedures that are in there, and we can do show create procedure to actually view the contents of a particular stored procedure. So I can say, how about display? What does display take? So display, alright, so it just, it doesn't take any parameters, it's just shorthand for select star from names. So that might be a good demonstration to make use of. So all we have to do with there is it kind of works like prepared statement in terms of how we parameterize it, but these need to be the actual arguments this method takes. So display, for example, doesn't take any methods, so it doesn't take any arguments. Add name takes two arguments, so it takes a name and it takes an age, and so we would pretty much call that in order to add something. What else was there? Delete person. Let's have a look at that one. So we have a look at delete person, and that just takes a name. So name, age, and just name. So we can make use of this in order to set up a callable statement. And that's called prepare call. And we just use we just type out the SQL call command with however many parameters we want. So let's say add name, question mark, and then, okay. The parameters are around the other way now, so we'll just swap them because the string comes first. So set string, I should say, put me in here. I'm 99 years old. Okay, and then we'll just, oh, I don't really want execute update, or do we? I think we might. I think execute update is a reasonable thing to do here. Let's just see if it works anyway. Ooh, no. Invalid callable syntax must be like call procedure name. That's because I added that semicolon. Let's try it without the semicolon. Okay. Yeah, the semicolon is necessary when you're typing in SQL, but not so much for when you're making use of the JDBC. So now I can select star from names. Yay. And just to restore the integrity of the database, I'll make use of delete person in order to get rid of me. Let's comment that out. We only have one parameter. Execute that. Rows affected 1. There we go. That's the basics of making use of callable statements. And so the code for that is actually within this database here. We can just change the callable statement within the database, and that will change the behavior of our program without us having to go and recompile our program. So that can be quite nice for certain things. Okay, so cool. Yeah. Yes. Frequently, when you're making use of a database, you typically want to make use of, sometimes you will be doing quite a lot of work on that particular database. You might be performing a lot of different SQL queries in order to achieve something. And there's various considerations given to how we go about doing that. So even though prepared statements can improve your database access time, if there's 10,000 insert statements executed, there's a lock and release carried out by the database for each insert. Basically, the database wants to work even if you have multiple applications connecting to it and changing things. So the database is designed pretty much around transaction security, transaction processing, and so everything you do essentially belongs to a particular transaction. And so the database will pretty much lock down the things that you're changing and then release those locks once you're done changing them for every single insert. But a better way of doing that is with something like add batch. And so what you can do is you can, with a statement, you can add a batch of things that need to be executed and then execute that entire batch. And all that does is that it performs the the start of the transaction. It indicates the start of a transaction, it executes all your SQL, and then it concludes that particular transaction. But there are some caveats associated with it. You can't have a batch that spans multiple tables because only a single table is locked at a time. And so if it does, it needs to actually know in advance what tables you're doing all this work on. And a failure in the middle of a batch will cause all of the remaining SQL statements in that batch to fail. So there's some examples of that in this batch Java file here, where we can see what's happening here is that we have some code that basically uses add batch, and in order to set a whole bunch of things and then execute them all at once. And there's transaction processing, which is sort of a bit of a more advanced version of that. So the idea with transaction processing is that in some applications, there's SQL statements where you only want any of them to occur if all of them succeed. So for something like a funds transfer, you don't want, funds transfer might be accomplished by subtracting a number of funds from one account and then adding that number of funds to another account. But if either of those fails, you don't want to do the other one. You don't want to have money disappear, and you don't want to have extra money in the system. So the way that this works is that you can have them both being a part of one SQL transaction. And that way, if either of them fails, none of the stuff happens. And so the SQL server will just quietly roll back the so if the deposit, so yeah, if the withdrawal fails, then that gets rolled back, and so forth. Determining the boundaries of that transaction is the job of the application programmer. That's not something that the database server can actually work out for you. You won't want things to be part of a one transaction if they don't have to be for the most part, because it's kind of expensive to keep track of everything so that the database can roll back if there's a failure at any point. But the idea is that JDBC and the database management and the database software that you're using will then support that transaction processing. And so this is all about when these changes are actually committed. So by default, set auto commit is actually on, and the idea there is that when you're writing, when you're executing updates and things like that, the assumption there is that after you execute each one, that will immediately be committed to that particular database. If you don't want that, you can make use of set auto commit to false in order to prevent part of the transaction being automatically committed to the database. And then what you do is that once you've successfully performed all of the steps of your transaction, you then use the commit method, and that will apply all of them. If there's some kind of problem, you can make use of the rollback method to restore the previous state. JDBC3 also has these things called save points, and they're essentially breakpoints for transactions. So you can actually set a save point, and then if there's some kind of problem, you can then roll back to that particular save point. And that will ensure that you have the database that is at its full level of integrity at any point. Okay, so that's the basics of operating on connections and statements. Next, we're going to look at the thing that you get returned to you when you make use of a database query. Yep. Little Bobby tables. Okay, so result sets are used to store the result of an SQL query. So basically when you perform a query of some kind, and we'll just go back to, actually we've already got a callable statement here, so we'll just make use of the display method, which doesn't have any parameters, which is pretty nice, so we should be able to just call that. And what that will return to us is a result set. So statement dot execute query, and then we should be able to, actually I think we can get rows. I don't know if there's a method to give the number of things that were returned, maybe not. Either way, we'll just get our result set and then we'll start playing with it. So the idea with result set is that it essentially allows us to iterate over a 2D table. The idea with SQL is that a single query will, at the end of the day, result in some kind of 2D table at the end of it, where the columns are the attributes that were selected and the rows are the rows that were retrieved. And we can query that through this result set. The idea is that it's a 2D table of all rows in the database that match the criteria of the query. We can use get methods to get data from the result set. So this is like our set methods from before where we're setting the parameters. We can use get in order to get values out. Note that once again these are indexed from 1. So if you want to retrieve the first column from the database, you need to get column 1. And this is analogous to the list iterator over a collection. However, the result set is not an iterator, and it's not iterable either. So you'll have to make use of different methods in order to use this. And we'll see what the deal is with that. In earlier versions of JDBC, you could only move forward, and the result set couldn't be manipulated. from JDBC 2.0 onwards, scrollable and updatable result sets were introduced. So the idea there is that you can move back and forth or up and down the table that was returned, and you can even update the contents of it. Now, exactly what that will do will depend on some things related to how you did the query, but you can do them. So what we make use of here, okay, I will look at that in a little bit, I think. Okay, so I'm just going to go through how we make use of one of these result sets. So result set has a bunch of methods. Most of them are these get methods. So things like get int. In order to make use of the, and what you can see for each of these is that there's actually two forms. So there's one that takes a column index, which we've already sort of looked at, and another contains a column label. This can be useful for some things. Sometimes if you just do, if you do a particularly sophisticated select, it might not be clear what the name is of a particular label, although you can actually set the label. You can retrieve something as something else. But rather than needing to know what the column indexes are, sometimes it can actually be easier to select by column label, in which case we just put down the label that we want. For example, if we want age, then we don't need to know what actual value that was. We can just get some age, and then remember to close that result set. So let's just print out some age value that we retrieved from this database. Oh, we got an error. Oh, that's the thing I should also mention. The way that we navigate through a result set is with this method called next. And it pretty much works the same as the iterator, but it's both used to determine if you've reached the end and to get you to the next row. And the way it works is that the result set cursor is initially positioned before the first row. So you need to call rs.next in order to select the first row of the results. So we'll call that 75. So where did it get 75 from? Well, that is the first age number that appears in this table. So, but there's 4 of them. So how do we get the others? Well, that's easy enough. We just need to iterate. The way that rs.next works, both with it returning Boolean if there's nothing else to return, and with it needing to be called once before you can retrieve anything, makes it work very nicely within a while loop. So we just do while rs.next, put that in, and now we should be able to retrieve all of the different age values from this table. And depending on how many things we retrieved, we could retrieve a number of results that way. We can also get back, a name, so string. Some name equals rs.getString. And we might as well select this one by name as well. So we can then print out some name, colon, and then have a look at that. Alright, and so we've basically recreated the select star statement. In fact, I might just go back to just using a regular old statement. Create statement. And then putting in select star from names, just so that we can see how this stuff works. Okay, so now that we've got just a plain SQL here, we can just make use of the other things as well. So we can get everything where a is less than or equal to 62, for example. And this will just retrieve 3 rows from the database. And of course, where name equals, say, Peter Beattie, we can retrieve that. And of course, we can use a callable statement or a prepared statement here, especially if Peter Beattie is going to be replaced with some variable name. Then we can replace this with a question mark and specify using a set string in order to parameterize it. What else can we do? I mean, that's the main thing there. If we're doing something kind of fancy, like let's say we're doing select count star from names, we probably aren't going to want to try to retrieve name and age, because select count star won't actually have access to that stuff unless we get count star and name and age. But no, we just want to retrieve one thing, so we'll do rs.next, and then we'll do rs.getInt 1, because it is the first thing that we're returning, and we can run that, and then that should be able to count the number of rows that are actually in there, which it probably did, except I forgot to print it out. Rows. There we go. And we get 4. And basically, that because these are actually handled on the database themselves, this stuff doesn't need to be sent over anywhere or retrieved via the driver. It's usually going to be fastest to count the rows in a table, or the rows that sort of match some query. Let's say we had a name. Age is less than or age equals 57. We want to count the number of people age 57 in that particular table. It would most of the time it would be a lot faster to actually execute count on the database and retrieve that value than to say retrieve all of the rows and then count everything in the result set. And the same is true for pretty much all of these particular checks. If we want to retrieve only results that match a certain pattern, we want to get, get count names like so we just want to get everyone with a name starting with John. Then this this determination is happening on the database. I messed something up. What did I do wrong? Oh, where name like John, of course. So we do this, we can get the number of people whose name begins with John. So this is going to happen on the database itself, and it will be, making use of all of the database features that allow it to optimize queries like this, where we're trying to match, say, paths of names and things like that. That will normally be a lot faster to run on the database, rather than something expensive like retrieving all the results and then doing the filtering ourselves. So if you can do the filtering on the database, you probably should do the filtering on the database. Okay. So that's the basics of result set usage. We haven't actually been scrolling them or anything like that at this point. But what we can do is when we create the statement, we can actually pass in some things that tell it what type of scrolling we can do. So if we have a look at the different options for that, so when we create statement, we could look at dot type scroll. Let's maybe look at some of these. So type scroll insensitive means that it means that this is scrollable. It means you can go back and forth, but it's not really sensitive to changes. So if the data changes, then it's not designed to actually handle that. And then there's forward only, which means you can only call next. So if we make use of, say, type scroll insensitive, let's have a look at this. So we have to give it both our concurrency and our updatable. So result set dot concur read only we might do for now. Alright, and let's just change this to a plain select star from names. So what we can do, alright, we know that if we do rs.next, we'll be pointing at John Howard. So we'll just test that out. rs.getString name. Let's just test that. And if we go forward 2, we'll be looking at Peter Beattie. But if we go forward 2 and then go back 1, we will once again be looking at John Howard. So that's basically what the scrollable means. The concur read only part, where that comes into it is if we want to do something like a update int. Let's say I want to change John Howard's age. 30, why not? And then we'll get both the name and the age out of this. Age, get int. Okay, so run that. Ooh, okay, we can't do that because we have it set to read only. So that's basically what happened there. If we set concur updatable and give it a shot, it has not done anything. That's interesting. I sort of wonder if we just need to... Oh, of course. Let's go and just have a quick select for names. Alright, that hasn't changed. Good. Let's go and have a look back here. Oh yeah, there's a bunch of different methods for navigating. First and last, just to skip to the first or last row. Next, previous, which we've used. Absolute and relative allow you to jump around. So if you know you want to go to a particular row, so let's say, let's get rid of this one for now and do rs dot absolute pass in 2. I think this is also 1 based. Yep, first row is row 1, second is row 2. So row 2, Peter Beattie, if we change that to this. Okay. Next is relative, which will reposition it based on whatever the current row is. So I'm going to set that back to 2 and then try that again. So what that will do, I think we'll get Peter Beattie again. Yeah. So the current, when you first execute a query and get back a result set, it will be pointing to the row before the first row. We'll call that row 0. So when you do rs.relative, it will then add 2 to it, and you'll get to row 2. So if we did another rs.relative and we added in, say, 1 there, we would go to the third name on the list, Tony Abbott, and then we go to -1, and we will see we've gone to John Howard. So that's basically how you can move around quite quickly using these. If you know that you don't want anything after the first, you don't want anything in sort of the first part of the results, then you can skip around quite quickly using these methods. And then there's update. So yeah, the actual way that this ends up working does very much depend on how I've actually set things up. So let's absolute, let's go to 2 again. And we've got type scroll insensitive here. So when we do that, despite me updating the age value hasn't actually changed at all. Let's see what happens if we use type scroll sensitive. When we run that, the same thing has happened. instead the update row or update methods. Instead the update row or insert row methods are used to update that database. I think there is something else. I'll post. I'll have a look into this and actually post the message. I typically don't make use of updating rows within a result set all that much. It can be quite a powerful tool, but it's also a little bit dangerous to use. We have some actual example code here. We have nameplay resultset.java. We might actually have a look at that. So nameplay result set. I'll just check this and make sure I haven't changed any of the data in it. So now we could run this and see what actually happens. So what it's done here is that it's actually, it's made, you need to use update row after you've updated a value, of course. So let's rs.update row and then have a look at that. And there we go. So Peter Media's age has been changed to 30, and this also applies to the original database. So that's why it can be a dangerous thing to actually, change result sets around. But it's also a very fast way, because then you don't need to issue another SQL statement. You don't need to construct, an update command. You can just directly make use of these. And it can make use of whatever sort of internal tracking the JDBC driver has in order to do this nice and quickly. Okay. Alright, so let's go. Some execute opinions generate multiple result sets. So you can do various things. You can make use of get more result sets to work out if there are more result sets to return, and get result set to retrieve the next one. And so that's basically, cases where you've actually retrieved multiple tables within a single SQL statement. In fact, I might just try that out now. I don't know if it will work, but I'll have a look anyway, just so I can find out. So I want to see if there are, rs.get more, what was it? What was get results? Oh, I see. That's for the query, I think. Statement dot get more results. Let's just see if what this says. Moves to this statement object's next result. Returns true if it's a result set object, and implicitly closes any current result set objects. Okay, so what we can do is we can then go here, and then we will get another result set out. They'll both be the same because I'm just running the same query twice. But I'll retrieve something else here. Otherwise, I'll just say, no more results. I don't actually know if this will work or not. This is sort of a live demo experimentation, which is probably why it hasn't worked here. It doesn't like me, I think, selecting multiple, performing multiple operations within a single one. But that's fine. Okie dokie. Alright. So that's the basics for working with simple types. Now, SQL supports a number of different types. We've already had a look at some of them, and we can see them by having a look at the describe SQL command is pretty good at that. So describe names in this case will actually tell us the types of each of these values here. And there's quite a few types, so you'll need them when you're actually using create in order to create a particular database. Note that, like any other SQL query, you can create databases from, so you can create tables. I don't know if you can create databases, you probably can, just using, execute on statements. So if we want to create a new database, we could do something like, statement dot execute, create table, testing table, well, and we'll just put in blah is in 8, and blah blah it is varchar 255. There we go. That one actually can hold anything, but we'll at least see if it worked or not. I didn't throw an exception, so that's a good sign. So if we do show tables, we can see our testing table, and if we do describe testing table, we can see that. And we can make use of these other SQL methods to, for example, find out if we have our table, if our table actually exists, or we could just try and select from it and then do something in response to the exception. But either way, you know, you can create and destroy tables just fine from within the JDBC. Okay, so there's various types in there. So for example, we've had a look at int. There's also things like float and double in there. And for longer amounts of text, we have text and long text and things like that. And these are which can hold, I think text can hold 16 million characters. Long text can hold, I think, up to 4 billion. Depending on the amount of stuff we actually need to store in our particular text field. For short strings, varchar is most commonly used, and you'll have the maximum length of a string provided there. But for things that don't quite fit that model, sometimes you need a different type. And one SQL type that is used for storing sort of non-standard things are the large object types. And there's two main kinds. There's the blob or binary large object, and there's the clob or character large object. So clobs are pretty much used for large sections of text. But they're a bit different to long text in that SQL, the database, isn't really designed to be able to, say, select based on their contents and things like that. So they won't be doing any clever indexing or things like that. The idea is that you've just said to your database server that you just want a big block of text, and you don't really care exactly how it's stored. You just want this big block of text in there, and you will deal with all of the operations that need to be performed on it. So blobs and clobs. The JDBC provides support for these. Now, blob and clob support tends to be a bit database server specific. But, you know, in things like MySQL and MariaDB, a basic blob is 16-bit size, so 65,000 bytes. A 32-bit blob is, I think it's long blob, which allows 4 gigabytes of storage. These blobs are converted to byte arrays before being stored, and they're becoming increasingly important in cloud services and things like that, where you have data that doesn't really fit into a nice, neat, integer or text field type, but you still need to store. These could be images, sound files, anything like that. So how do you make use of those? Well, in a basic SQL statement, you might have something like, okay, so this is an example with a prepared statement. So we have this table called pictures, and it's clearly got at least 2 values. One is picture and one is name. And we can probably guess based on the names of these columns that picture is going to be a picture. So it's probably the binary large object. And so what we then do is we prepare that particular statement, and instead of using, say, set string or set int, we make use of set binary stream in order to point to the data. And then we can just execute that, and that will put our object inside there, whatever it is. This is also making use of the object output stream. You can see the second mini lecture, which is on network connectivity, and in that lecture I actually make use of object input stream and object output stream. These are basically ways of invoking Java serialization. So serialization is the idea of taking the contents, taking the state of a particular object, whatever it is, and turning that into bytes so that we can store it somewhere. The idea is that it has some kind of representation in memory somehow. It could be spread over multiple data structures or things like that. But either way, a serializable object is an object that can be where you can take all of that information that makes up the state of a particular object and turn that into bytes. And that doesn't necessarily work for all objects. For example, things like file handles on the system, which actually point to a particular open file, aren't serializable. Network connections aren't serializable. Anything that sort of depends on some living thing elsewhere in the system usually can't be serialized, but most other things can. You know, if it's an image, then you can serialize it just by storing the bytes that make up that image. And so what we have in this case is we have an image icon, and an image icon is just a data type that you can create from, say, a buffered image. So you might find these useful in, say, swing programming. But either way, you get an image icon, and the idea with this is that it then serializes that into bytes, and then inserts that by into the database by doing set binary stream in order to say, all right, this is, you know, this is a stream and it contains this many bytes, and that will then just be stored in your database. You can then retrieve it in much the same way. So what you can do here is that you can you do you use your result set, and you do get blob on your column name. That returns a blob object. And then what you can do is that you can actually get from your blob. You can use, so on the blob you can use this method called get bytes, which will actually just return the bytes that belong to that particular blob. And that also appears to be 1 byte, so the first byte being 1 there. And so what it will then do is it will turn your bytes into, it will create an input stream from your bytes using, you know, byte array input stream, and then you can use that to create an object input stream, and then retrieve an object which you can then cast into your image icon. This is fairly safe if you know that this thing was actually an image icon in the first place, and fairly dangerous otherwise. There are checks you can do. For example, you can get this returned object here, and you can do if object stream.read object instance of image icon, and then give some kind of warning otherwise. But otherwise this will just throw an exception if there's some other problem with it, so it's generally pretty fine. So, we might as well just give that a quick test. So, just to see exactly what happens, first we will need a table that actually supports a blob. So we'll need to do, say, grep table, blob table, and we'll have name, bar chart if I find, and then we'll have, I think it is, let's call this object, and we'll make it, I think it's long blob. We'll get an error if it's not long blob, and I'll just store it as a blob instead. Describe blob table. Okay, that looks pretty good. Alright, so now let's see if we can store something in our blob table. So let's go back to this. Okay. We don't need to change the database. We might change our statement type, just set it back to the default. And now we want to insert something in here. So we'll do statement.execute update. We'll get the rows so we can print out. Okay, so execute update, and we'll want to do, say, insert, in a string, of course, insert into, maybe a prepared statement would be better. Yeah, I think so. I think we want to use a prepared statement because we can't really type a blob. So we'll call this one prepare statement. And we'll say, insert into, what do I call that again? Blob table. Values. First. No. Question mark. Do believe it was. Alright. And then statement dot clear the parameters. Set string. First one. My test blob. And then the other one we will need to statement.set. We can actually take a blob that we've gotten from some other source and just do set blob with it. So that's nice. I wonder if set bytes would work for this as well. Var binary, probably not. So instead we likely want a binary stream, or maybe one of these two. We can play around with that. Either way, I'll just do that. I'll use statement dot execute update, get those rows back, and then print out rows updated plus rows. Okay. So then make sure we don't have results set this time, so I don't need to close it. Okay, so now we just need to put something in that blob. So if we have a look at the example here, let's see, this one's probably the way to go. We just need to pick some serializable type and it will be our blob, and that can be pretty much anything. So what we've done here is we've created an object output stream and then we've used write object on it to affect the byte stream. Okay, so let's do byte array object output stream BAOS byte array output stream, and we will pass, don't pass that anything, and then we will create an object output stream OOS new object output stream, and we'll pass in our byte array object stream, handle the exception, and OOS.write object, and we can put in whatever object we want. We'll just make this my object for now, and then we can, let's make it a string. Hello world. So this will be quite different to actually just storing a raw string in there. We probably won't be able to see it in the database ourselves, just by doing a select, but we can still perform this. So set string and then statement dot set binary stream. That's the second parameter. And we'll just pass in, byte stream to byte array. BAOS.toByteArray, and then I think we need to give it a length. That's why I did it in 2. So create a new byte array input stream with that data. Alright, so let's do the same thing. Byte data equals, and we'll byte array input stream data, and we'll get data.length so we can tell it how many bytes there are to expect. And we'll just execute that, and that should add something to our database. And we'll even rename this like they've renamed. We'll call this insert statement, so that we'll create a new one later on. So let's run that, and we'll either get an exception or we'll get rows updated 1. So now let's actually just select star from blob table. Okay. Oh, that's interesting. It actually does have a go at displaying it. So what we've got is some bytes here, which is sort of the Java serialization stuff. Part of this will also be the length of that hello world string, and then we have the text hello world. So we can actually sort of see that, and we'd probably see a bunch of garbage characters if we were using, say, an image or something like that. But either way, we can take any serializable object and we can store it in a database using this method. And so now that we've got something in that particular database, we can go and let's comment this stuff out in case we want to use it later. And let's go and make something to actually retrieve it. So this time we can just make use of a statement. Query blob, just query statement equals new. No, not new. We want connection dot create statement. Query statement dot execute query. And this time we will just select star from, what was the table called? Blob table, of course. That will return a result set. And then we can look at that result set and we can navigate to the first row and then get out our binary stream. I wonder if we can just get the bytes out directly. Let's see if that works. We'll get the bytes out for column 2. So that will give us some data. I'll make this byte data, get bytes. And then we should be able to take that data, object input stream OIS equals new object input stream, and we'll pass that. Oh, we can get an input stream. And so that probably wants to take a new byte array input stream, and that can take our bytes. So this is a little different to what the lecture was doing, but that's fine. And then we should be able to just is.read object. Who knows what it actually is, but we'll just get object obj equals is.read object. Add the exception, and then we can do some things to actually look at the contents of this object. So we can see, for example, obs.getClass. What did I mess up? Ah, typo. So we should be able to find out what class it is. Also, what I called OBS. It's obj. Obj. There we go. And we can see what the toString method returns. So that should just be the text if this is a string. So let's now run that and see if we've managed to retrieve our object. Ooh, we have. Oh, I didn't use print line. Let's just fix that up. Run that again. What do we get? Alright, so it's a Java lang string, and it can, and if we call toString on it, we get the text hello world. And we can do that with any object as long as it's serializable. So we can create our own objects and make them serializable quite easily. There's also an example of that in the same network connection mini lecture, so I won't go into that. The example in here is using an image. So, but you can serialize any object that is serializable in Java, and store that into your database. So we could see, for example, so let's comment this bit out here, and I didn't close. I have no idea. I didn't close the result set, and I didn't close the statement either. Alright, so let's say we go back to this one, and we go and put something else in. So let's say my other test blob. Okay, and then we'll put some other object in there. So they used an image. Let's try something like, I wonder if there is image io.read. I can then read in any image I like. So I could say, I don't really have a handy image around to use on this, I don't think. Let's not worry about that. But you get the idea. You can store any kind of object in there. If you want to store a number in there, let's say 3.14, we can do that. So this 3.14 will be turned into a double, and that double will then be cast to an object, and then it will be stored in there. So this will also be very different to just storing a number in a SQL database. We'll actually see, oh, it's even got the class name there, so Java Lang double, and then probably in binary somewhere is the actual value of this double, but I certainly can't see it. However, that doesn't matter, because Java knows how to deserialize it. So we can just select out of that, uncomment this, turn this into a while loop so we see everything that we've retrieved with that statement, and then retrieve that. So we can see that we've stored in there, we've got a Java Lang string with hello world, and we've got a Java Lang double with the value 3.14. So using that, you can store whatever you like in a database. It's a very powerful tool. Okay, so that's pretty much it for large objects. So in summary, databases are used for managing large structured data, and Java needs to be able to interact with the database either through a vendor-specific JDBC or the ODBC JDBC bridge. So if we look back here, this MariaDB Java client is the JDBC driver. Once again, the topic of actually installing MariaDB and installing the database driver is covered by a mini lecture, but that's fairly straightforward. If we go to project structure, we can also see that this JDBC driver is properly in there as a dependency. So we can see it in modules, and I think we can also see it in libraries as well, because we just add our JDBC driver as a library this way. We can add multiple if we want, and then use the get connection method, which will then choose which will then select based on this which database driver gets loaded. Java then interacts with the database via statements. So we've looked at the statement interface, we've looked at prepared statements, which are a little bit faster, but also more secure, less vulnerable to SQL injection attacks. And we've looked at the callable statement, which is used for basically pre-programmed statements that are stored within the database itself. Statements return result sets, and you can iterate or update those If you have it set so that you can update that result set, then what happens is that will actually change the underlying database, so be careful of that. But that can be a convenient tool for quickly updating results. For example, if you say have a JTable that points at a result set, you can actually set that JTable so that editing the cells of it updates the result set and therefore updates the underlying database. And we've looked at how large objects can be handled with blobs and clobs. I didn't actually look at clobs here. They're pretty much the same as blobs, except they are designed more for characters, and so you might give them, you pretty much interact with them in the same way. So, homework, if you haven't already, you probably want to install MariaDB and check out the examples. In that database connection mini lecture on Blackboard, I actually go through the steps required there. Have a look at the JDBC ODBC bridge and talking to other databases, and understand how all of this stuff connects together. And these are just some references. Next week's practical session is just doing some work with a database. So database and GUI, opening a database connection, retrieving entries from an address book, and so forth. This week's practical session is just GUI based. So in this week's practical session, you'll be following a worksheet, and that worksheet will just step you through a bunch of different tasks. So the take home for today's lecture: databases enable applications to deal with large structured data. Java can interact with a database via the JDBC adapter, and we've looked at how we do all of that in a practical setting. And thank you very much. We've got a little bit of time. I might just leave the stream open in case there's any questions people have about databases, but otherwise, thank you very much. This is sort of a bit of a weird setup, but I think it works fairly well for our sort of purposes. And yeah, for the rest of the semester, I'll be doing these types of live lectures. All right, thank you very much.